Okay, so welcome to chapter 2 review of the C++ programming textbook here by Malik. And again, this video is not meant to be a replacement for this textbook. This is additional supplemental material where I want to kind of walk you through each one of these chapters and point out what I believe is important. So if we go to chapter 2, let me find it down here. You'll see that chapter 2, in chapter 1, we learned the basics about computers and the IPO paradigm, input, process, output, and we created our first Hello World program. In chapter 2, we're going to learn these things, but the important part is that we're going to learn how to store data into variables and how to access those particular variables. Okay, so yeah, the introduction of chapter 2 goes over at a high level, right? What a program is, basically a process of planning and creating a program, right? Okay. So the next page introduces us to a pretty good example here. And I don't think they've introduced a lot of these concepts presented here yet. But what we're going to learn is, we learn in chapter 1 that the basic program consists of including the libraries we want to use, in this case IOStream for input and output, having a int main function that every program starts with, and then we put whatever code that we want to run inside of that main method, right? And I think the very first program we talked about, or Malik talks about in the first chapter, is using the cout statement to present hello world, right? Or whatever it might be. We can use cout to print strings to the screen. Well, and now in chapter 2, we're going to learn that we can create variables, and each of these variables that we can create has what's called a data type in front of it. All right, computers are stupid machines, and we have to let the computer know exactly what type of data will be going inside of each one of these variables, and that's what this is. And you'll learn later on that a double is basically a number with a decimal point in it. And there are other data types like int and bool, and chapter 2 goes into each one of these data types. So if this doesn't make sense to you yet, don't worry, that's the whole purpose of this chapter. And once we declare these variables, we can actually assign them to a value. And notice that once we assign variables a value, we can actually use those same variables in another equation to calculate and create a value for another variable, right? So having these variables declared and the ability to store values is very important. It allows us to do a lot of computational work, and it allows us to process data. Okay, so pretty important chapter, and it gives you, at least this very first subunit, an example of how to declare these variables and print them out. Remember, cout outputs data to the screen, and we can actually see out these variables and see what their value is on the screen. Okay. Right. So I suppose we could do a little bit of this. Maybe not the entire program, but yeah, let's go ahead and fire up Visual Studio. I did have a chance to install Visual Studio 2019, and this is what we're looking at here. This is Visual Studio 2019. Very similar to 2017, but I do like some of the improvements for sure. So anytime we want to start coding, right, we always want to go File, new project, right? File, new project. And they made this new project screen a little bit friendlier. Let's go ahead and create a console app, a C++ console app, because we're learning C++ right now, and in particular console applications, which basically means an application that sends text or characters to the screen. We're not really doing any graphics or anything like that. Okay, so let's create that console app. Let's give it a good name. Maybe in this case, we'll call it Chapter 2. Okay, this is where it's going to store all of your code. Is in this folder here. So if you're new to programming, please write down whatever this location is so you can find this code later on, especially if you have to work on an assignment for school and you have to turn it in. You're going to need to know where this location is. And this is going to be different for everybody. Your professor is not going to know where you're storing your files to. Okay, so make note of that if you're new to programming and you don't realize where your CPP files are going, or your C++ files. Give it a nice descriptive project name. Go ahead and click on Create. And we will see that we have a new Chapter 2 project in the solution window here. We will see that we have a new chapter2.cpp file within our source files folder. And we'll see that it opens up this new file for us called chapter2.cpp. And yeah, this is definitely much friendlier than what it used to do with Visual Studio 2017. Notice that it lets us know, right? This is what's called a comment. I think we went over this in Chapter 1, but anytime you see a / these are notes to the human. The computer completely ignores all these lines with the / in front of it. These are known as comments, and so Microsoft added these comments to kind of help out the new programmers and say, hey, this file contains a main function. That's where the program execution begins and ends, right? Remember, we learned about that main function, and we learned that these curly brackets, open curly, close curly brackets, define where the main function starts, where the main function ends. Okay, what does it currently do? Well, it's printing out hello world, right? With what's called this cout statement. A lot of people don't like to have to put this std : in front of every statement. So if you want, you can always, it's called using namespace. And if we do this, then we can remove this std declaration everywhere. All right, so this is basically what we learned in Chapter 1. What is it that we're learning from the book in Chapter 2? Well, let's try to declare a variable here, maybe a variable called length. Okay, and this length variable is what's called a double. Okay, notice I am indenting by 4 spaces because we are inside of the main function. What did it want us to call it? Length. All right, so let's create. And all right, so that statement right there creates a variable. Well, maybe let's do it. Creates a variable called length that is a decimal type. And we'll learn about all the different types later on. What we can do with that now is we can actually assign it a value. Okay, whatever value you like. And then we can actually print it out to the screen if we like. Cout length, or maybe what we could do, be a little bit friendlier. The length variable value is, okay, length variable value is length. And now when we run this, okay, I don't see any red exclamation points. I don't see any red underlining. That means that the compiler should be happy. So let's come up here and hit the green run button. And we see that, aha, it did exactly what we wanted. The length variable value is 10. Okay, so so what it did was it took length. It said, hey, what's the value inside of length? Oh, that's 10. So let's go ahead and output that to the screen. Okay, so that's in a nutshell what they're trying to demonstrate here. But again, this is kind of a preview, and we're going to learn about all of this within chapter 2. These figures down here want you to understand that when you create a variable, you're doing what's called memory allocation. You're actually signifying that there is a spot in memory reserved for each one of these different variables. And each of the variable data types can take up a different amount of memory, right? So for instance, the double data type, I think, takes up 8 bytes. The int might take up 4 bytes. The string takes up, well, it depends on how big the string is, right? So the key is that each one of these variables does take up some room in memory. Okay, and we'll talk about why that's important later on. But for now, just know that every declaration that you make within your program, you are allocating memory. Okay, and at some point, if you create too many variables, the computer is going to run out of memory. Okay, now luckily we live in the 21st century where we have 8 gig, 16 gig, 32 gig of memory, and we don't have to worry so much. Okay, however, on embedded systems applications where you have a small CPU, well, you have a CPU on a embedded board, typically they have small amounts of memory, and you do have to be very careful with how many variables in memory that you are allocating. Okay. All right, let's move on to the next section here. The basics of a C++ program. We're going to see that we can divide these programs up into what's called functions. We already were introduced to one function, and that is this function here called main, and that is the function that every program begins with. But we'll see later on that we can create our own functions. Anytime we see maybe there's a section of code that we want to call over and over again, we can create our own unique function. Or there's actually some predefined functions that we can use as well if we import the right libraries. Okay, so yeah, keep that in mind. We already kind of talked about syntax in chapter 1, right? Every C++ program has a specific syntax, which means when you start a function, for instance, right, you got the return, the return type, the name of the function. You always have parentheses, right, after the function. You always have the parameters that apply to that function inside the parentheses. You always have these curly brackets that specify where a function or code block begins and ends, right? And we always have this wonderful semicolon that everyone who is new to C++ just loves because they forget to put it every time, okay? And so there's more syntax rules than just that, but the key is that we have to get the syntax just right, or otherwise, if we don't get the syntax right, remember, if we remove the semicolon here, all of a sudden we get some red squigglies and we get the compiler complaining when we go to try to run. It yells at us and says, no, there's all sorts of errors. I have no idea what you're talking about, all because you forgot one character. Okay, so syntax is very important. Okay. Right, enough about that. We have the ability of specifying a comment, which we actually just went over a second ago, right? Where if we put slash slash in front of the line, we can leave comments behind that slash slash, and that is purely for the human. The computer completely ignores these comments, okay? So we always have the ability of creating comments. Notice that you can create a comment at the end of a line of code, if you like, okay? Typically that's, yeah, you can do it, but most industry usually wants comments to be on their own line above whatever line it is that it's referencing, right? So usually I would put this above here, not to the side, because the problem is that on smaller screens, if you have this comment off to the side, you may not see it, right? The code may run off the side of the screen and you may never see that comment. So in industry, typically you want to put the comment above the line that it applies to, or above the code that it applies to. Now, the other thing you can do is actually what's called a comment block. So if you have a lot of lines of code that you want to comment out, for instance, maybe I want to comment out this whole program. Why? Who knows? But we go /*, that's the start of the comment. And then wherever we want that comment block to end, we put //. Okay. And what that does is that comments out everything in between. So if you have a whole section of code, maybe 1,000 lines of code, you don't want to delete it, but you want to try something else. You want to try something new. This is an easy way to, comment out that code so that the computer or the compiler can't even see that code block. Okay. What else? Special symbols. Yeah, a lot of these mathematical symbols are special symbols that are used to perform math. These are what's called Boolean conditional operators. Well, actually, this can also be numeric operators. And then a lot of these are used by C++ to denote the end of a line or put in between parameters, right? The comma, a decimal point for a number. So there are some special characters here, special symbols that are reserved. We cannot use those inside our variable names, for instance, right? Variable names can only, and I think it'll talk about that here shortly. Variable names can only have alphanumeric characters in them and none of these special symbols. Okay. We also have keywords, right? These are very special words that C++ has reserved, hence the name reserved keywords. And what that means is that we cannot use these also as, let's say, variable names when we are storing values. And as we go, as you go through the book, you will see that we'll be introduced to what each one of these mean. You're not expected to know what each one of these mean just yet. Just know that if it's a keyword, you'll see it, for instance, in Visual Studio, it'll turn blue. Okay, and that means, hey, that is reserved. I hope you're using it right. Please don't use it as a variable name because the compiler will not allow that, right? We wouldn't be able to call a double variable double. That would be, it would yell at you. Okay, so keywords we cannot use as variable names. All right, identifiers, right? That is basically the name of your variable, right? All of these variables that we can declare are known as identifiers, and they do have some restrictions. One of them is that we can't use the keywords. We just talked about that. Another one is that they are case sensitive. And what that basically means is that in uppercase and lowercase letters are different. So if we declare this variable called first with a lowercase f, and later on in the program, we try to use this same variable, but we use an uppercase f, that is two completely different things to the computer or to the compiler, and it will yell at you when you try to use the uppercase F1 because it says, I have no idea what that is. I only know about first when it has a lowercase f. Okay, so case sensitivity, a lot of people who are new to programming, it takes them a while to get used to that. What else? What else? Oh yeah, no spaces. You cannot have a space inside a variable or identifier name. So if you want employee salary, either join them together without a space, or you can put an underscore. You are allowed to use underscores in between the two. I think it is industry standard now to just use, this is called camel case, where the first word is lowercase, and anytime you start a new word, you use an uppercase letter. So if you had a bunch of words, you would know where the words end and begin by where the uppercase letters are. Okay. Cannot use special characters, right? So if you try to use an exclamation point inside the variable or identifier name, it's going to complain. All those other special symbols that we saw about on the previous page, the plus, the minus, the multiply, can't use any of those inside your variable or identifier names. Also, you can use numbers, but it can't start with a number, right? So we could use, for instance, employee salary 1 at the end, or employee salary 2 at the end, but you can't begin the variable or identifier with a number. Okay, cannot begin with a digit. All right, white spaces. Yeah, there's white spaces, and it'll probably go into that. We'll probably go into that a little more later on. Data types. There's lots of different data types. We'll see there's simple data types, there's structured data types, there's pointers. But we'll get into the specifics of that later on. Just know that there's a bunch of different data types. Okay, let's talk about the simple data types. These are your basic data types that most programs use, and they fall into these three categories. And these are all numeric. Integral, which basically means an integer, a whole number that does not include a decimal. Something called a floating point, which is a number that does include a decimal point. And something called an enumeration, which is kind of like creating categories for your program, where they kind of like the different colors of the rainbow. Until we see an enumeration used in a programming example, it's hard to explain. So the two that you should really focus in on right now is an int, or an integral, which is a whole number, and a floating point, which is a number with a decimal point in it. Okay, here's some examples, right? Here's an int. So when we declare these variables in our programs, these are the data types. Notice it's not using the whole word integral. It's just using int, right? Not using the whole word Boolean. It's just using the word bool. Char stands for character. All right, we're going to see that we can store a single character in memory, right? A single character from the keyboard. Or a long, if we want a really big number, a big whole number. Notice this long does not contain a decimal in it. Okay, so if you want a decimal, I guess we're going to go over that here in a second, because I don't see a float anywhere in here. So for whole numbers, it's either an int, bool, char, or long. And these are the values that it can represent. So notice that if our number is going to go above and beyond, well, there should be a positive. I don't know why it's listing negative on both sides here. It should list positive 2 bazillion to negative here. Here it does, right? Negative 128 to 127. Even here, yeah, these are typos. This should be negative to positive, negative to positive, negative to positive. Okay, notice that the storage in bytes, if we declare an integer, it takes 4 bytes in memory. If we declare a long, it takes 8 bytes of memory. Why? Because a long is a huge number, and we need more bytes of memory to represent that huge number. Okay. Here's an example of each of the different data types. A Boolean data type basically allows you to store 2 values, true and false. And we'll see that that becomes important later on when we run conditional statements, and we need to know if a particular condition is true or false. And if we chain enough of these together, well, now we have artificial intelligence, right? Where we can create branches of logic based on a true or false condition. And again, I'm kind of jumping forward a little bit, but that's why you have this Boolean data type. Character data type is anytime you want to store a single character. That can come in handy when you have a menu-driven system and you want the user to just type in one single letter or number. Okay. Floating points, right. So remember we were talking about whole numbers on the last section. Now we're talking about a data type that allows us to store numbers that contain a decimal point in them. And that is known as a float or a floating data type. In order to declare a float, kind of odd, they don't have an example up here. You put the word float and then the name of the variable. But I think this section is trying to point out what a floating point number looks like, right? This is in normalized form. This is in scientific notation. This is in C++ floating point notation. And if none of that makes sense to you, I don't think you really have to worry about it too much. Just know that a float can hold numbers that look like this, right? So if you have an accounting application or a scientific application, more than likely you're going to be using a lot of floating point values, right? Because you want precision. Okay. What else? Okay, so when we use these different data types, in order to declare our variables, and we kind of saw that at the beginning of the chapter, we have to put the data type first and then the name of our variable, right? So for example, if we want an integer called counter, we say int counter. If we want a floating point variable called interest rate, we say double interest rate. If we want a variable that holds a single character called grade, we say car grade. Okay, and this is pretty common with all the languages. You have an int, you have a float, you have a car, you have a floating point variable. Okay, some of the newer languages like Python will actually figure it out for you, and you don't even need to call out what data type it is. But some programmers like that, some programmers don't like that. It is safer for the programmer to determine which type should be used. Okay, so this section here is just really outlining that you need a data type in front of your variable name, and we went over the different data types that are available. All right, now order of operations. This is, it's the basic PEMDAS, right? Please excuse my dear Aunt Sally. That is the order of operations that the computer will execute. Yeah, here's a good example of declaring another program that takes inches, right? And here we see that inches is an int or an integer. We put the value 100 in inches. We display that inches to the screen. We divide it by 12 and display that to the screen. And that will tell us how many feet we have. And this line here takes the number of inches modulus 12, which basically means what's the remainder, and it displays the remainder, and that will tell us the remaining number of inches. Okay, so if we put 100 inches, we'll see 8 feet, 4 inches. Okay. What else we have? Oh, again, order of precedence, right? So if it has a big, if we type in a big equation like this into the program, it's going to follow PEMDAS. Please excuse my dear Aunt Sally. It will do the multiply first, and then the divide, and then the add, and then the subtract. Right? Multiply, divide, subtract, then add. Oh, well, the reason I did the subtract first here is because they added parentheses. And that's why it was forced to do this minus before the add. All right, so I don't think you have to worry too much about that unless you are dealing with some complex mathematical equations. But in any case, I would always suggest using parentheses anyways. You don't ever want to come up with a formula like this and let the compiler determine the order in which this is evaluated. Just add parentheses everywhere you need it so that you can be ensured which of these operations happens first, right? That's the beauty of parentheses, is we can force the order of operations that we want. Okay. Expressions. Yeah, we can have expressions that are integers. We can have expressions that contain floating point values. The only reason this really matters is because right here we've got apples and apples, right? We've got nothing but integers being added, multiplied, divided together. And the answer to these equations will create an integer as well. Okay, so if we have nothing but integers, the result will be an integer. If we have nothing but floating points, the result will be a floating point. The question is, well, what happens if we mix apples and oranges? What happens, and that's what this mixed expressions is about, if we take an integer plus a float, or we take an integer divided by an integer plus a float? Now all of a sudden we've mixed the apples and the oranges, and there's a bunch of different rules. Just know that the compiler will automatically either downgrade this to an integer or upgrade this to a floating point value. But I would suggest never mixing apples with oranges. Okay, when you're creating your program, if you do have an equation like this, just make, if you want floating point, make everything doubles. If you want an integer, make everything integers. And obviously there are some exceptions to that rule, but I would say pick one or the other. Don't let the compiler look at this and make a determination for you as to if the answer should be an integer or a float. Okay, there's always, we'll talk about typecasting later on. You could force this to a float so that it automatically has a float plus a float, and then you won't lose this 0.5. Okay. Typically you want to, all right. So there's a bunch of different rules here, and these are all the rules that the compiler will look at to figure out, well, is the result an integer or a float? I would say I don't think you need to memorize that, but just know that when you're mixing apples with oranges, you're not sure if you're going to get an apple or an orange, and you definitely needed to do some testing to figure that out. And once you figure out what that result is, maybe you want to do some, typecasting, exactly what the next section is going to talk about here. All right, so there is a way to force one data type to be another data type. And that is exactly what this section here is talking about. For instance, if we have this value 7.9, but we determine, we don't care about the 0.9, let's force it to an integer. We can do what's called a static cast and specify what new data type we want it to be, right? So maybe we want to take a floating point value and down, it's called downcasting, right? And get a little less precise and downcast it to an integer. Or maybe we want to upcast. Maybe we want to take an integer that is the number 25 and cast it to a double so we have more precision, right? So we can have a 0.0, you know, and typically the reason you do this casting is exactly what I was just talking about a second ago, where we don't want to mix apples and oranges. So we want to cast, you know, either an integer to a floating point because everything else is a floating point, or we want to cast a float to an integer because everything else in the equation is an integer. Okay, so you do have the ability of static casting values and variables to a different data type. Now, it may not be possible for all data types, right? We can't take this integer, or I'm sorry, 7.9 and static cast it to a string. That doesn't make any sense. So there are some limitations. We can't just make magic happen. But as long as it makes sense, typically you can static cast it from one numeric type to another. Okay, and they show you an example of that down here. All right, so unfortunately, that's all I have the time for today. Please continue to comment on the video. Let me know if I'm glossing over a section that maybe I should go into a little more in depth and provide feedback. I'd really appreciate it. But otherwise, next time I'll pick up here on the string type within chapter 2. Thank you very much for watching.